Hello everyone, welcome back to the channel. Today we are going to get a quick mental model of how training works in Azure Machine Learning. We are going to use automated machine learning in the Studio UI to train a classification model with no coding. We will deploy that model as a real-time endpoint and test it. But before we get started, thank you for liking, subscribing, and sharing this channel. And also, please check out our product, cloudmysite.com. With this, let's get started. If I choose the ML option, this will be the Azure Machine Learning. So we'll start with the 60-second overview where Azure Machine Learning basically gives you a few different ways to submit training jobs. You can use the Azure CLI or Python SDK to submit a command job, which is what many official tutorials use. You can use automated ML, where you just bring data and target column, and Azure ML tries multiple model and hyperparameters for you. And you can also build pipelines when you want an end-to-end workflow with data preparation, plus training, and deployment. Under the hood of all of these end up as jobs running on some compute resource like a CPU or GPU cluster. And the log metrics, register models, and so on. First, we come to Machine Learning Studio, and we need to create a workspace. So we will create this workspace, give a friendly name, and this is where we don't need a hub because it is not a shared resource. You could leave the default subscription, a new resource group. I will just choose YT demo. I'll choose Central because I've observed Central US has lesser issues compared to other ones. So I'll just make it ML YT demo and hit click create. Now that our workspace should be created. It'll take a few minutes and we can revert once the workspace is created. So our workspace is created. We click on it. And this is where we will see all the information, which is notebooks, automated ML, the pipelines, jobs. Now we will create a new notebook. So a notebook is an interactive document where you can write code, run it one cell at a time, and see the output right below it. It is perfect for data science because you can mix code, charts, text, and experiments all in one place. In your machine learning notebook is ideal for experimenting with data, trying out different models, and document what you did, all inside your Azure ML workspace. Click Create Compute. And now this is where we need to choose the instance family. And here we will just choose the standard is good enough, which is memory optimized, 6 cores. You have the option of CPU versus GPU. For now, we'll just choose CPU. And click Review Plus Create. You can have these other configurations on what setup you require. Click Create. So once this cluster is created, you will be ready for training jobs to be run here. Let's give it some time and we will return once it is created. So now we see our notebook created. So now for data ingestion, Azure Data Explorer handles raw data in like CSV and JSON, along with like other data formats such as Avro, JSON, Parquet, and like, so that is where we will use the small data set to train the model. So we will download a sample data, which is a data set that is readily available. And this is the credit card client data. So we have downloaded the data. We can view the data. It is just some test data. So in workspace that you have, click on automated ML, new automated ML job, give the job name. In this case, I have bank credit card data. I'll just use that and new, and you could just give the same with a previous demo. Tagging is something you should do. I'll skip for now. And I had this, let me delete the data, but let me click this. But let me create a new one. Actually, before I do, let me select the task type, which in this case is classification. because we are doing predictive modeling. And I'll choose credit card data. And in here, I'll choose a new one. I'll choose Tabular. It's a CSV format. And I'll choose from local files. Next. And I'll leave it default. I'll upload a folder. I could do upload file as well. Overwrite if file exists. Click next. So the data is now loaded. Now you could do next. These are the different columns that you are seeing. Next, and click create. So AutoML will choose the model for us and do the predictive modeling. But let me select this one, which is the right one. Click next. And task type, it is classification. Target column is Y. And in additional settings, like enable deep learning if you want, and this is the additional configuration settings. So you have these AUC weighted, leave it default, or you also have accuracy, but for now I'll choose either one. And you can choose the class label, the custom training time, and just I'll leave it default. Click save, and click next. And the compute type is I'll choose the compute instance that I had created earlier. This is the one I had done. It is running. Click next and submit training job. I could always have chosen serverless, but since I have it, let's use that one. So this is the job details. And let me check the job status. So this is where you can see the job is running. The job is still running. It has been quite some time, and this can take around 24 to 48 hours, depending on the amount of data that you have provided. I have provided a 3 MB file, so it will take a good amount of hours. But I think you get the point that it is a lot simpler with Azure ML, where we can deploy the model and we can also have a real-time endpoint. So how is this different from the classic trainer model tutorial that you will see in the documentation? In that tutorial, you typically write the Python training script, define an environment, then submit a command job from a notebook of the CLI, and use that to train register and then deploy the model. What we did today was use automated ML in the Studio UI. So no training script. We let Azure handle the algorithm selection and hyperparameter tuning automatically, and still ended up with a registered model, still deployed to a managed online endpoint. And we can still inspect jobs, logs, and metrics in the same workspace. So you have seen an alternate path that leads to the same destination. I deployed production-ready model, but with much less boilerplate code and a more visual experience. What you learned is how ML thinks about training jobs in compute. You used AutoML in Studio to train a classification job model with no code. You deployed that model into a real-time endpoint and tested it. And you saw how this compares to a more traditional command job tutorial. So drop in a comment if you want any custom writing, training script or any other models that you want to know, and we can always produce it for you. But this was a quick overview of AutoML and how you can use your data set to come up with different model categories, predictive modeling, classification modeling, NLP, vision, and get the required output with next to no coding. With this, thank you for liking, subscribing, and have a good day.